Welcome to Probability Tree Diagrams. In a previous email for tree diagrams, we looked at how we label the columns. So we have a start, we have a column for each stage, and then the outcomes that are produced from those stages along the branches. Today we're adding a probability column. This is because our branches will have different outcomes and different weightings on them. Note the probability is written on the branches. We multiply across the branches, and the probability column has to add to 1. So here's our example. In a bag there are 4 green and 6 white balls. We're going to choose 2 from random, with the first being replaced before the second selected. So what's the probability of choosing 2 green, a white and a green, and at least 1 green? So let's have a look at how our actual probability tree starts. So we have the start, we have ball 1 and ball 2 because that's what we're choosing. We've got the outcome and the probability. So our first ball can be green or white. And then off each of those, we can also, for our second ball, choose a green and white. And note our outcome. So this is similar to what we did before. We just followed the branches. So the top branch is GG, 2 greens. Second branch is a green followed by a white. Third branch, white followed by a green. And the final branch is 2 whites. Now we're going to introduce the outcomes on. So the probability of choosing a green was 4 out of 10. And the probability of choosing a white is 6 out of 10. So now we move into the second branch. Now because we put the ball back, the probability of choosing a green again is 4 out of 10 and the probability of choosing a white is 6 out of 10. So that second ball, the probabilities for green and white are the same as they were for the first branches. So if we move across the top branch, so to get a green, the probability is, as we move across the branches, we multiply. 4 on 10 times 4 on 10 gives us 4 25ths. And if I do that for each of the branches, so the second branch, green-white, is 4 on 10 times 6 on 10. The third branch, 6 on 10 times 4 on 10 to get white-green. And the final branch, white-white, is 6 on 10 times 6 on 10, which gets us 9 out of 25. Now you will note all those probabilities down in that column, 4 on 25 plus 6 on 25 plus 6 on 25 plus 9 on 25, get me 25 on 25, which is 1. Showing that the probabilities of all outcomes add to 1. Let's answer our questions. So the probability of green. I only have to go to the top branch where it says GG, follow it to the end, and I get 4 on 25. The second question was the probability of getting a green or a white. Now, we can get a white followed by a green or a green followed by a white. And if you follow both of those branches, you get 6 on 25 and 6 on 25. So we add those together because it's green, white or white, green. And we get 12 on 25. For our final one, the probability of at least 1 green. Now, this could be any of the top 3, GG, GW, WG, and add those together. Or we actually can do 1 minus the branch that doesn't exist. So 1 minus the probability of white. So 1 minus 9 on 25 gives us 16 on 25. Let's look at a second example. This one a little bit more difficult than the first one. So the same bag, we've got 4 green and 6 white. 2 are chosen from the bag. After the first ball is chosen, a ball of the opposite colour is replaced. So if we choose a green first, we're going to put a white back in. And if we choose a white first, we're going to put a green back in. What's the probability of choosing? And the same questions as the last one. All right, so same setup. Start, ball 1, ball 2, outcome and probability. All right, so ball 1 could have been green and white. Ball 2 was the green, whites again. And then you get your outcomes. Green, white, green, white. So let's just start with the first ball. So our probabilities of getting a green from the first ball, there were 4 green out of the 10, and the white, there was 6 out of 10. Now let's look at the green, the green ball being chosen first. So when we chose a green ball first, we took the green out and we put the white back in. So we had 4 green to start with, we're down to 3 green, but now we've got 7 white. So there are 3 out of 10 chances of getting a green and 7 out of 10 chances of getting a white. Now let's look at the other alternative. What if we'd chosen the white first? So if we'd chosen the white first, well, we have 1 less white, so we started with 6, we're down to 5. So we got 5 white left out of the 10, and we put a green in. So we started with 4, the green would have had 5 in there now. So now let's look at our probability. So multiplying across, we get 4 on 10 times 3 on 10. For green, white, 4 on 10 times 7 on 10. For white, green, 6 on 10 times 5 on 10. And for white, 6 on 10 times 5 on 10. All of those outcomes add to 1. And this is important again when we go to do at least 1. This is a good reminder. So, the probability of GG, well again, straight across the top. GG is 3 on 25. The probability of WG, white-green or green-white, so we follow those branches. So green-white is 7 on 25, white-green is 3/10, add them together, 29 on 50. And our final one, what about the probability at least 1 green? So again, we could have added the top 3 branches, GG, GW, WG, and we would have got the same answer as 1 minus the branch that doesn't exist. So 1 minus 3/10 gives us 7/10. Thank you.